Good morning, class. Today we're going to be looking at Notes 1.04, Graphing Inverse Functions. And so today, by the end of today, we will be able to find the inverse of a function written as a table, and we will be able to graph inverse functions. Okay. Um, and so to talk about inverse functions, we want to go back to uh, Algebra 1. Maybe you haven't thought of it this way, but we actually have been using inverse functions to solve equations without even knowing it. Okay, in Algebra 1, when you found things like the additive inverse of 3, it means, what's the opposite of a positive 3? In this case, the additive inverse of 3 would be negative 3. Right? Because when you add 3 to it, it gives you 0. So the additive inverse of 3 is negative 3. The additive inverse of 3 is negative 3. The other inverse that you may have seen in Algebra 1 is the multiplicative inverse of 2. The multiplicative inverse of 2. It means, what's the opposite of multiplication? Division. So if I multiply 1/2 times 2, that equals to 1. And so the multiplicative inverse of 2 is 1/2. The multiplicative inverse of 2 is 1/2. Okay, but using it in Algebra 2, the inverse of a function is defined to undo a particular function. It undoes a particular function, it does the opposite. Another thing about the inverse function for f of x, it's usually denoted by f with a -1 and then of x, parentheses x. And you usually read it as f inverse of x. Okay. So a couple of things about that. Let me move this page up a little bit. It's right there. The domain and range of the inverse function is the opposite of the original function. In other words, the domain of f of x is the range of f inverse of x. Remember, when we have f to the power of a -1, we say this is the inverse, and then the parentheses x is of x. So inverse of x and vice versa. So keep in mind what's being said here, and I'm going to highlight some key things. So in other words, it says that the domain of f of x, so I'll box that in purple. So what's the domain of f of x in the example down here in the tables? The domain of f of x, remember, domain are all the x values. So if we analyze the statement again, it says the domain of f of x is the range of f inverse of x. So if I look at the f inverse of x table, what does it mean by range? We're talking about the y values. So what are the y values of this table? These values. Okay, so in other words, just looking at the tables, it's saying that, two functions, in this case, this function on the left here and this function on the right, if these two functions are inverses of each other, then the domain of the original function, f of x, is the range of the inverse function. The domain is the same as the range. And if we compare these two lists, They are the same, right? But that's what this statement is saying if I break down the statement. Okay? So let's look at the instructions for the examples, okay? For examples 1 through 3, we're going to find the inverse of each function represented in the table and state whether the inverse is a function. Okay, so we're going to do two things. Find the inverse and state whether the inverse is a function. So let me slide over to example 1. Okay, so you have example 1 here. And one thing we have to keep in mind is when we're looking for the values in given a table, you have to do what's called swapping the x and the y values when you're going from the original function to the inverse. So let's say, this is the original function, and this is the inverse. And so when I want to go from the original to the inverse, if I want to make the table of the inverse values, it's just a matter of switching the x's and the y's. Okay, so I'm going to switch them. It's going to be, remember what we said earlier, the domain of the original is the range of the inverse. So if you want, you can copy these first. And then the y values we're going to copy over here on the x. Okay. So remember, when we want to go from the original function to the inverse, we have to swap the x and y. We have to swap the x and the y. And then the question is the inverse a function? The table that we just made, is this table, is it a function? Are these set of points a function? So we have to go back to what's the definition of a function? And so the definition of a function is a function does not have x's that repeat. So a function should not have any x's that repeat. So if I look at the inverse table and I look at specifically the x values, are any of the x values repeating? No. So that means that it is a function, because a function does not have the x's repeating. So we're going to say yes, the inverse is a function. We're going to say yes, the inverse is a function. Okay. Let's go to example 2. Example 2. So I'm going to kind of do what I did in example 1. I'm going to say, okay, if the function that is defined as f of x, we're going to identify it as the original. this one is the inverse. Okay, and so we need to go from the original to the inverse, we need to swap the x's and the y's, right? So if I do that, my x's are going to, I'm just going to switch them over. So 1 over 100, 1 over 10, 1, 10, 100. And then I'm going to switch the x and the y. So -2, -1, 0, 1, 2. So we're just switching all the x's and the y's to create this new table. And so again, they're asking us the same question again. Is the inverse table that we just filled out, is that a function? So remember, for a function, the x's cannot repeat. A function means that the x's cannot repeat. So do any of the x's repeat? Do you see it more than once? No, right? So none of the x's repeat. So then we could say yes, this is a function. Okay. Now let's look at one more table. And again, doing the same idea, if I have the original, then this is the inverse. And in order to find the values for the inverse, we need to swap the x and the y. So if I do that, it's going to be 4, -2, 1, -1, 0, 0, 1, 1, 4, 2. And then we have this question again, is the inverse, the values that are here, is the inverse a function? X's, it means x's do not repeat, right? But wait, I noticed that there's 2 x values that repeat here. There's 2 x values that repeat. So there's more than one x that repeats. So we would say no. This is not a function. Okay. And so there's something that we're going to need to do in this situation. And we'll talk about that more when we get to, graphing these functions. So, but for now, we're just going to say, okay, I noticed that the x's repeat, and so the inverse is not a function. Because remember, to be a function, the definition of a function as far as the tables go, we need to check the table and see if the x's do not repeat. Okay. If they do repeat, then it's not a function. We'd say no. Okay. So let me go ahead and move over to the next page. And so now we're going to be looking at graphing inverse functions. The graph of an inverse function is the reflection of the original function over the line. of y equals x as seen below. Okay, so the color kind of came out here, here in blue, and let me add some details here. For example, this graph has arrows here and arrows here, and then we have a red arrow here, red arrow here, and this is, just to kind of highlight some pieces here so that the colors come out. Shade in the red and the blue parts. Okay, so what it's saying is, if I have a graph and I want to find the inverse using a graph, what I can do is I can draw the line y equals x. We've drawn this line before. It's the diagonal line, and it's going to be used as a reflection line. Okay, so if you notice things like for example, if I pick this point on the blue graph, and then I pick this other point on the red graph, notice how far apart are these points? Let me use a different color here. Let me use something like pink. Okay. So if you look at these 2 points, if the purple line is the mirror, these 2 points are a reflection, right? And actually, the blue and the red graph are a reflection of each other if the purple line is the mirror. Okay, so that's the idea here, is that when you draw this purple line, this diagonal, it serves as a reflection line, like a mirror line. Okay, so that's the first step you want to do. You want to draw the reflection line. And then you want to graph the inverse function by reflecting the function points over the reflection line. And then use a red pen to graph the inverse function. Okay. So what we're doing also is kind of color coding and making sure that the original function is one color and the inverse, or the reflection, is a different color. Okay, so that we can kind of tell them apart and know which one is the original and which one is the inverse. So let's practice these steps a little bit in the examples, and then we should be able to get a better idea. And I'll show you, two ways that we can look at this. So let me zoom out so that the whole thing comes out here. I'm trying to find the best angle for this. Okay, I think I found it. All right, so first step is to draw the reflection line. And since in the picture they use purple, I'm going to use purple. The reflection line, and I'll use an arrow to kind of show where the reflection line is going. It's basically the diagonal. It's if you want to think of the linear parent function that we drew like 2 class days ago, it goes like this. And you can use a ruler if you have it. But this is the reflection line. So this is the line y equals x. Okay. And I'm going to call it, the reflection line. Okay, there's 2 ways to do it. You can find the coordinates of the point and then switch the x and the y. So like for example, if I look at the coordinates of this point, then what's the coordinate of that point? So if I write it out here, it's 1 comma, sorry, 3 comma 1. 3 comma 1. So remember what we did on the previous examples with the table. To find the inverse values for the table, we switch the x and the y. So if I switch the x and the y, instead of using 3, 1, what if I switch it? So it would be 1, 3. 1, 3 would be right here. So this red point here, let's see which way is it going to go. Okay, it's going to go this way. So it's going to be, this is 1 comma 3. So you can do that. You can keep this going. You can pick this point. You know, what's the coordinate of this point? It's 0, 2. 0, 2. And then if I switch it, it'll be 2, 0. 2, 0. Okay, that's one way to do it. You know, looking at the points and then switching the numbers and graphing that new point. Or you can also, you know, if I do away with the points or the coordinates, what I can also do is look how far the points are to each other. So let me erase this again and kind of give you another option here. And so if I do, let me pick a different color. So if I see, for example, that how far is this blue point to the diagonal, if I go in the opposite direction and reflect across this purple line, I will get a point that's over here. Okay. Same thing if I go from this blue point over here, you know, how far is it to the line of reflection? If I go the same distance in the opposite direction, I get this point. And actually these are the same 2 points that I drew earlier. And then we can do the same thing over here. 1, 2, 3. So for example, this point is 1, 2, 3 steps away from the line. So if I go 1, 2, 3 steps this way, I can end up with that point. So it's going to be 1, 2, sorry, 3. So it's going to be up here. Okay. So however you wish to do it, you can do the points, you can do this system that I'm doing right now. But let's try the points. I want to try that again. So for example, if I do the points, let's say I do all the coordinate points, I'll make a list over here. X, and y. So it's going to be, what's the coordinate of this point here? -9, 5. -9, 5. Then what's the coordinate of this point? -6, 4. Then what's the coordinate of this point? -3, 3. Then 0, 2. 0, 2. What's the coordinate of this point? This is 3, 1. What's the coordinate of this point? 6, 0. And then the last point here, 9, 9, -1. So then if I make a list of x and y over here and I just switch them, I switch these. So if I switch -9 and 5, it's going to be 5, -9, 4, -6, 3, -3, 2, 0, 1, 3, 0, 6, and -1, 9. So all I'm doing is I'm using the points that I got from this blue line and then switching them to get the inverse points. So if I graph this first one, 5, -9, that's going to be 5, -9. 5, -9. 4, -6. 3, -3. 2, 0. 1, 3. 0, 6. And -1, 9. Alright, so if I connect these points, I'm going to use a ruler. Give me this line here. And the question down here is, what type of function is the inverse? You know, if the original blue graph that's on there is a line, what type of graph is the red line that we end up with? What type of graph is the inverse? Is it also a line? So we would write down here that the type of function that the inverse is, it's also a line. It's also linear. Okay. Now let's look at the square root example. For this one, I'm going to zoom in and then zoom back out, just so that I have the grid there. So the square is a little bit smaller. But the first step is still the same. The first step is to graph the diagonal. So let me graph this diagonal line here. And so again, this diagonal line is like my line of reflection. I'm going to use the reflection method, and I'm going to use a different color here. So I'm going to say, how far is this point to the diagonal? It's one step away from the diagonal. So if I go one step in the opposite direction, so I'm going to go one step over here and then plot my first inverse point. Then I'm going to see how far is this blue line, 1, 2, 3. How far is this, not blue line, how far is this blue point to the diagonal? So it's 1, 2, 3. 3 steps away. So if I go 1, 2, 3, then if I go 1, 2, 3 diagonals, I get this point here. So again, how am I getting these red points? By reflecting the blue points, using the purple line as my line of reflection. What about these 2 points? Are they, are these 2 points, are they on the diagonal? If something is on the diagonal, then it stays where it is. Okay, so we just copy it or kind of draw over it. And so my inverse graph will be something like this. Okay. And the question about it is, is the inverse function, what type of function is the inverse function? So if we look at it, it has points like 0, 0. Doesn't it look like one of the parent functions that we've seen? Doesn't it look like half of a U shape? This red graph? It looks like half of a U shape. So what type of function is the inverse? We can say it's like half of a quadratic. It's like half of a quadratic, because remember the quadratic is a U shape, but this red graph that we drew is about half of it, right? Then we look at the cube root, and again I'm going to zoom in here. First step, draw the diagonal. Then these 3 points in the middle here, these 3 points are on the diagonal, so I'm just going to copy them. But this blue point, if I figure out, how many steps is it away to the diagonal, let's measure it. So it's going to be 1, 2, 3 steps away. So if I take 1, 2, 3 steps on the opposite direction, then that would be my reflection point, right? Again, this is if the purple line is my mirror. I'm reflecting this blue point across it to get this red point. Now let's do kind of the same idea with this one. How many steps to the diagonal? It's 1, 2, 3 steps. So if I take 1, 2, 3 steps, I end up right here. And so if I connect these red dots, I end up with the following. But doesn't this graph look familiar as far as, maybe one of the parent functions that we've seen? Because the blue one is the cube root function that we saw. But isn't the red one another parent function that we saw last class? it's called the cubic function, if you remember. Cubic. Again, because it's asking us what type of function is the inverse, what type of function is the red graph. So it's like a cubic from our previous parent functions, right? And then we're going to look at one more. Next one is, what type of function is the inverse in this case? Okay, so first step again, draw the diagonal. You always want to draw this diagonal because it kind of serves as a kind of like a reflection line. And then we're going to reflect the blue points. So let's start over here. So I'm going to go 1, 2. It's like 2.5, right? 2.5 steps. So I'm going to go half, 1, 2. So that's going to lead me over here. And then I'm going to do kind of the same idea over here, over here. It's like a half step to the diagonal. So I'm going to go half step over here and put a red dot right there. Because my goal is to reflect this point, okay? And then the same idea with this point over here. It's going to be a reflection. Okay. So then if I draw it, it's going to look like the following. So I'm going to be coming this way. You know what? Let me use a different color because there's already a red line there. So let me use orange. So I'm going to color these dots orange. I'm going to go this way, go up, and then go up this way. Okay. And to remind us, I drew the inverse in orange. So what type of function is the inverse? And so if you remember the functions from last class, we had logarithmic and exponential. So the logarithmic is the blue graph, and so the orange graph is the exponential. Okay. And that brings us to the end of our examples for today. Again, next class we're going to be going over an assignment that's based on these notes. But you know, if you saw the notes and we still have questions on it, you know, we can go over it during class. But thank you for joining me in this video note session, and I'll see you guys next class. Have a great day.